We're going to be looking at proportional reasoning, and the method we're going to use to solve this question is a scale factor. It's also known a lot as constant of proportionality. Both of those are interchangeable. The overall expectation is solve problems involving proportional reasoning, and the specific expectation is to solve for unknown value in a proportion using a variety of methods. So we'll read our inquiry-based question here. We'll read through it once, highlighting important information the second time through. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is the tree? Okay, so flagpole information will highlight in yellow. A flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. And our tree information will do in green. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is the tree? Okay, this is describing in a relationship, so let's put a diagram of this if we can. Anytime we get a chance to do a diagram, I try to. It usually helps me visualize what's going on. So our black line here is going to represent our flagpole. Okay. And the gray line is going to represent the shadow. The shadow was 2.4 meters in length, and the height of the flagpole was 6 meters. We'll also represent the tree. We'll use another line for that. This time we'll do it in green. And the tree will be a little taller. And I can tell this because I know the shadow of the tree from our information was a little longer. It was 4 meters, which would, by deduction, mean that all other things being the same, the tree's height, which is still unknown, we'll use x to represent it, is probably higher than the flagpole. Okay, so we said we're going to use a constant of proportionality here. We're going to set up our category. So we have our flagpole and our tree. Okay. And if we kind of use a dotted line, we can kind of connect these. And what we've built are similar triangles here. Because they're similar triangles, we can kind of set up a factor between them. And a lot of times with similar triangles, if you're ever solving a question regarding them, we can multiply our values. All angles will be the same inside. Okay. And our lengths, okay, there'll be some number we can multiply by to figure out what our lengths and heights are. Okay. So you can set this up with just our diagram here. Actually, it's probably going to be very helpful. I just need to figure out a value that goes from our flagpole to our tree. And the reason I want to figure out the factor going from our flagpole to our tree is because I have more information about the flagpole than the tree. If I found a number to go down from 4 to 2.4, it's not as helpful because I wouldn't know how to apply to the x because I don't know the value of x. Okay, so, but we will show you how that will work after anyways. I need a scale. I need to go from 2.4 to 4. And a way we can figure this out is take the larger value, or the number we're going to, and divide it by the number we start from. Okay, so we take our end value and divide by our start. Okay, in which case that would be 4 over 2.4, and this will give us our scale. Okay, so for our scale here, we use our calculator. We take 4 divided by 2.4 is equal to 1.666. Okay, so because this is a repeating decimal, our scale factor is 1.6. I want to be as accurate as possible. If I just round it to like 1.67 or even 1.7, there's going to be some rounding errors. So let's try to keep this as straightforward as possible, as accurate as possible. What that means now, to figure out the height, okay, and because these are the two pieces of information that are the same, these are the heights, these were the shadows, that's why we knew they were the same. I'm going to use my scale factor to multiply up again. I'm going to multiply by my 1.666. And really, even the calculator around it only went to so many spaces. Luckily, this calculator keeps the numbers from before, so I'm going to put it in. I'm going to multiply by my value of 6, and I get a value of 10. So according to this, our tree is 10 meters in height. Now, remember we talked about how we could technically go backwards. Say we found another scale, and this will just maybe use a scale for checking. Okay, let's take, let's say we're going the other way. Okay, well, we take our start, or we take our end number and divide by our start. So if we're ending at 2.4 and we start at 4, we take 2.4 and divide by 4, and that'll be our new scale in this case. Okay, so our scale the second time through 2.4 divided by 4 equals 0.6. Okay, so if I multiply 4 times 0.6, I'll get 2.4. Let's see if that works for here. If we multiply 10 by 0.6, do we get 6? And if you know your multiplication well, you'll notice that that's true. That works. So that scale worked both times. If you found it hard to visualize, another quick way you could have set this up, so we had our flagpole category in our tree, okay, and maybe we put our height and our shadow. The height of the flagpole was 6 and the shadow was 2.4. And the tree height was unknown, and sorry, I'm going to get rid of this line in the middle, and the shadow of the tree was a value of 4. You can think of it like this. I just set up my equivalent values, my shadow, and we figured out we had to multiply by 1.6, repeat it, and I would just do the same thing over here if you didn't like the diagram above, and it would give you the exact same value of 10 meters. Okay. If you'd like to look at other ways to solve this question, you can check out our other playlists on proportional reasoning.